Alright, so let's go over some interview questions in computer science. So firstly, I'm starting with DBMS, and in that we'll be discussing about SQL, right? So the question is, what is a join in SQL? So joins in SQL refer to the rows. Basically, they refer to the combination of two or more tables based on a shared column. So there are different categories of joins. We can have an inner join, which returns rows when both the tables have a match. Then left join returns all the rows from the left table that we are joining, even if the right table has no matches. Then right join returns all rows from the right table, even if the left table does not have any matches. Full outer join returns rows when one of the table has a match, so it could be either one. Self join is a SQL statement that joins a table to itself as if it were two tables, temporarily renaming at least one table. And Cartesian join, cross join, returns the Cartesian product of two or more joined tables set of records. Right? So you can go through all these. So SQL basically. Okay, so I'll go over this in depth in another video. So let me just complete another thing. So go over to the next question. Explain processes and threads in the context of operating systems. So basically, a process is a running program that serves as the foundation for all computations. The process is not the same as programming code, although it's very similar. In contrast to the program, which is regarded as a passive entity, a process is an active entity. Hardware state, memory, and CPU are among the attributes held by the process. Within a process, a thread is a single sequence stream. Threads have the same properties as the process, which is why they are referred to as lightweight processes. Threads are executed one after another, giving the appearance that they are running in parallel. Each thread has a unique state. Each thread has a program counter, which is a PC, right, a register set, and a stack space. Threads are dependent on each other since they share the code, data, and OS resources. So this is how it looks. This is a thread, and it basically comes from a process. Process stores the program counter, the code, data, files, registers, and stack. Now, explain the working of Ajax, which is asynchronous JavaScript and XML. Is a set of web dev approaches that can generate asynchronous web apps using various client-side web technologies. Right. So this is detail about Ajax. You can go through it. I'll put the link in the description. Right. Now, we'll be moving on to some of the coding questions. So, given an array of strings, you need to remove strings which are anagrams of strings preceding them in the given array. You need to return the remaining strings in sorted order. Okay. For example, T8 anagram eat gram man is the input, and the output comes out to be this. So you need to remove the strings which are anagrams of strings preceding them. Anagrams of the strings preceding them in the array. So remove those strings which are anagrams of the string preceding them. That means that the previous anagram in the string should remove, basically when you check later on, should remove all the anagrams that are existing. So for T, the anagrams existing are 8 and eat, so it would remove these two, right? Similarly, anagram, this word has its anagram, gram, and we need to remove this one. So the output comes out to be this. So 8 and eat are anagrams of the word T. Due to the fact that grammar is an anagram of anagram, the array becomes this, right? So that is the question. So the approach is simple. We can simply sort and compare the given two strings, right, to see if they are anagrams or not. We may also use a hash map to see if a string has appeared or not. Make an auxiliary array to show the generated strings, as well as a hash map to keep track of the string that we found so far. Then iterate through the array supplied string, sort the current string, and look it up in the hash map. If the current text is not found in the hash map, insert the sorted string array of I in the resultant array. After that, sort the array and print each string. So that's the answer. So let us go over the code, right? So vector string result would store our answer, right? And unique anagrams is the main function that we have. We keep an unordered set of string elements, basically to store the found elements, right? To keep track of already encountered sorted string. So we go over all, basically we have the array, so we go over all the indices, right? 0 to n minus 1, right? Because we are not including n. So we go over all the indices and check for all the words, right? So current word is array of I. Sort the current string. So the current word we have sorted, and check if the current sorted string is present in the data structure already. That is, if it is present in the found unordered set. So if found.find current word is equal to found.end, that means we are not able to find the current word. So if we are unable to find the current word in the set, that means it has not yet been included in the set. So we include it in the set first. Found.insert current word. So we add the current word in the set, and also push it back into our result array, right? And basically we have taken a set, so none of the anagrams would come, right? So that's the main, that is why we have sorted the current string, right? So that we get all the anagrams of that particular word and check if it is present in the set or not. And since set has the property that it stores only unique elements, so the anagram in the sorted fashion would come in the answer, right? So now moving on, let us go over to another question. So this is the next question. Explain BFS versus DFS. So BFS is a vertex based method that begins at the root of the tree and traverses all nodes at the current depth level before moving on to nodes at the next depth level. That is breadth first search. So we are going breadth wise or level wise. It employs a queue data structure that follows the first in, first out principle. In BFS, one vertex is visited and marked at a time, then its neighbors are visited and placed in the queue. Now, as opposed to that, we have DFS, which is an edge-based approach, right? So BFS was a vertex-based approach, while DFS is edge-based. It employs a stack data structure and operates in two stages. First, visited vertices are pushed into the stack, and subsequently, if no vertices are present, visited vertices are popped. So DFS goes into the depth first, right? So basically, from this example, you can see level-wise we are traversing. So we get A, this is level 0, right? Then we have B and C covered at level 1, and D, E, F covered at level 2. So that is the BFS. And similarly, we have we have the DFS, right? So we go for A, then we go for B, then we go for D. So we are going depth wise first. And then when we come back, we see B is already visited, marked as visited. So we come out again. A is also visited. Now we go on over to the next step, that is C. And then we go to E and come out and go over to F. So we're going depth wise here. So that is the difference in BFS and DFS. So BFS stands for BFS, breadth first search, and DFS stands for depth first search. BFS employs the queue data structure to determine the shortest path, and DFS uses the stack data structure. This is one key difference. Then, since BFS reaches a vertex with the fewest number of edges from a source vertex, it can be used to identify a single source shortest path in an unweighted graph. While in DFS, to get from source vertex to a destination vertex, we may have to traverse through additional edges. BFS is better at finding vertices that are close to the specified source. When there are solutions that are not close to the source, DFS is better. BFS has time complexity of O of V plus E when using an adjacency list, and O of V square when using an adjacency matrix, where V stands for vertices and E for edges. DFS also has O of V plus E using adjacency list and O of V square when adjacency matrix. Here the siblings of node are visited before visiting the children. As you saw, the siblings are visited first, since we are going level wise, right? So for example, this is the tree that is given to us. We are going level wise, right? So if we first cover level 0, then level 1, then level 2. So basically, siblings are covered first. That is, nodes on the same level are visited first before visiting the children. While in DFS, children of a node are visited before visiting the siblings. So you saw basically in the binary tree what is given to us, we visited the children first in depth first search, right? Not going level wise. So we go first to the children and then we visit the siblings. That is this part, right? So that is the difference, and yeah.